Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 20 in our incredible new tutorial series where you are going to learn Fusion 360 or you're going to die trying. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to teach you is I am going to teach you how to fine-tune and sharpen your parametric design skills. And the way I'm going to do that is I'm going to show you my solution to the homework assignment that I gave you in lesson 19. And that was to take that eyeglass case that we designed in an earlier lesson and to redesign it using good parametric design principles. Now, what you have to understand is using good parametric design principles is more than just going in and assigning a variable to every dimension in your sketch. Good design principles is to define right relationships between related parameters. And that's what I'm going to show you today. The second thing I'm going to show you is keeping in mind on your design the difference between driving parameters and driven parameters. What would be an example of driving parameters? Well, if we go to that eyeglass case box that we had made, the driving parameters would be kind of like the length, the width, and the height. That's how big the box is. But now I consider the thickness, the wall thickness of the box to not be independent or not to be driving. I consider it to be driven. A great big box would need what? Thicker walls. A little bitty box would need what? Thinner walls. The wall thickness is driven by the overall size of the box. And so I want you to keep that in mind as I go through this design. And if you can sort of start thinking the way I do, thinking like an engineer, you're going to be able to do very complex designs that are very easy to edit. Okay, sound like fun? I hope it does. Let me get out of your way. And let me have a little bit of coffee here. Do you notice a cow behind me right there? Do you see there is a cow right there munching on some grass out there? That's first for TopTechBoy.com. Have a cow in my video, but I digress. We'll come back later and check on the cow again, but let's hop over here and let's look at this design that we were supposed to parameterize. Again, this was the eyeglass case, and when we originally did it, we did it just based on putting in a whole bunch of dimensions. But I today will show you a better way to do it, and I will take you through that step by step. Well, when I look at this, I'm just going to kind of think out loud a little bit, but my thinking out loud might be some of the most important part of this video. First of all, what I see is length times width times height. All right, I'm going to need those as parameters. Then I'm going to need a wall thickness, a thickness of the wall. That is going to depend on the overall size. If I have an average length, width, height of a certain number, I think I would want the wall thickness to be about 0.05% of that, or 0.05 times the overall length, width, height of the thing. So the bigger it is, the thicker the wall is going to be. So I'm just sort of scoping that out. Then I'm going to need to have a parameter for the roundness of this corner. I could make that very clever and have that be driven, but I don't want this video to be too long. So I'll go ahead and I'll make that one an independent variable, a driving variable. Now you can see that I am considering this thing in the assembled mode, and so the height is from the base, the bottom of the base, to the top of the cap in the assembled form. And so like from here to here would be the height. Now what you can see is we can put this seam, this join between the base and the cap anywhere we want. I want to think of that as sort of like a percent. I could put that seam at 50%, in which case the case and the base would be the same, or I could put it at 10%, which would be kind of strange, or I could put it at 90%, but I want that to be a parameter. Then if I do that, then I will end up with a certain cap size, and then that cap size, I want some fraction of that cap to be the overlap. So you see, here is the overlap, here is the overlap, this overlap and this overlap are the same, and I want that to be a fraction of the height of the cap. Okay, so you see, this isn't going to just be a number I put in. It's going to be something that depends on the overall cap height, which depends on the overall height. All right, now just stick with me. Believe me, you're going to see some magic happen here. You're going to see some magic happen. But that's enough talking for right now. Let's come over here, and what you're going to find is most of the work is going to be in setting up our parameter table. So I'm going to come under Modify. I'm going to say Change Parameter, and I'm going to just start making these parameters as I talk out loud. So first of all, let's start with the obvious ones. The obvious one is the width of the case. So I'm going to call that case, uppercase W. And then I think the case width, I think I would like that to be about 35 millimeters. So case width is going to be 35 millimeters. I will say OK. Now I am also going to need, I will create a new parameter, case L for case length. The case length I think I will have at about 25 millimeters. So I'm going to say that is 25, like that, and I'll say OK. Now we're going to have a case height, so I will say case H. And then on the height, I'm looking down at a ruler. I think I would want about 110 millimeters, so I will have the overall assembled height 110, like that. So now I've got length, width, and height, so that's pretty good. Let me go ahead and put that curvature, that rounding parameter, and so I will call that, what do I want to call that? I'll call that case R for how round it is, the radius of the case rounding, and we'll put that at about 5 millimeters. That'll be a nice round on the edge at 5 millimeters. I think that will be pretty good. Now I am going to come in, and now I'm going to do a driven parameter, and that is the thickness. Now I could make the wall thickness 10% of the width, or 10% of the length, or 10% of the height. But then all of a sudden, you know, if I had something that was 25 by 50, the wall thickness is going to be different than if it was 50 by 25, which would be exactly the same case, but now the wall thickness would be different. So I want kind of a parameter that I think of as an overall dimension. And so that overall dimension, I'm just going to average the width, the length, and the height. And that's going to be kind of like my overall size parameter. So I'm going to come in and I am going to call this is going to be the wall thickness. So I'm going to call it case T for case thickness. And then that is going to be this overall size. So I'm going to open my parenthesis and I'm going to call it case H plus case L plus case W. All right, now I am going to divide that by 3, so this is kind of like the average dimension of the case, and then I'm going to multiply that by 0.05, meaning for that average dimension I want the wall thickness to be 5% of that. I want the wall thickness to be 5% of that, and then I am going to say that as OK. And boom, now I have this case thickness. That is a driven parameter. So I've got width, length, height, I've got radius, and I've got thickness. Now let's come back over here. Now how far up do I want this seam? What percentage of the height do I want that seam? So we'll come back over here and we'll go back to our table. All right, and so I'm going to call that seam, S-E-E-M, I hope it's S-E-E-M, seam percent, and I'm going to set that as at 0.75. So I want it 75% of the way up, 0.75. Now, a little pro tip here. 0.75 is a number. It is not in units of millimeter. So you have to come up here and say no units. If you don't say no units and try to multiply this by a dimension later, the thing won't work. So if you're putting a ratio in or just a number, make sure that you don't give it a unit. A pro tip there. So that's going to be seam percentage. That's 0.75. Well, now I have an overall height, which would be from here all the way up here, including the cap. How high is the base from here to here? I'm going to call that base height. Okay, I'm going to call that base height. And so here I'm going to add a parameter, and it's going to be base h, and that is going to be what? That is going to be the case h times what? Time that seam percent that we just put in there. Okay, so now, why did I create that parameter even though there's no new information there? Because when I extrude this, now I can just extrude this by what? I can extrude this by what? By the base height. And so I've got that number already in there for that extrusion. Now I'm going to go ahead and I'm going to make a cap height. I'm going to make a cap height. How high will the cap be? How high will the cap be? Let's come in here. Let's say change parameters. I'm going to create a new one, and that is going to be cap h. And how high is that going to be? Well, it's going to be, again, the case h times, now not the seam percentage, but 1 minus the seam percentage. So if the base is 0.75, then the cap should be 0.25, so they add to the 1. So this is going to be case height times 1 minus the seam percent. And if that doesn't make sense, draw a picture that the ratio of the base and the ratio of the cap, those two ratios have to add to 1. All right, so now I have got this dimension and I have got this dimension, and now what I need to do is I need to calculate this overlap. I need to calculate this overlap. Well, this overlap is just going to be the cap height times this ratio here. Did I put that ratio in? I don't think I did. So let me come back over here. And that's not good. What I need to do is I need to come here, and I need to come back over here. And so I've got the seam percentage. Now for the cap, what percentage of the cap do I want overlap? So I will call that overlap percent. So I'm going to call that overlap percent. And then that I'm going to make at 50%. So whatever thickness, whatever height the cap is, I want 50% of that to be the part that's overlapped. So the overlap percent, I would multiply by the cap height, and then that will give me the magnitude of the overlap. Okay, overlap percent is not 50, it should be 0.5, and then that needs to be no units as well, because it's it's a fraction, it's not a millimeter. So that should be good. And so now I've got the cap height. Now I've got the overlap percent. Now what I want is actually how big is the overlap? How I know that it's 50% of this, it's 50% of the cap height, but now I want to put a number on it. Okay, I want to put a number on it. So now what I'm going to do is I will add a parameter, and that parameter is going to be overlap height. Okay, overlap height. What is the overlap height going to be? It's going to be the cap height, cap h, times the, and what did I call that? overlap percent. Overlap percent. The cap height times the overlap percent. The cap height times the overlap percent will give me this dimension overlap. And that one will be the same as this. I hope that makes sense. Guys, go back and watch that again. Make sure you understand what I just did. So now I've got this dandy set of parameters, and I'm sure I'm forgetting something in there somewhere. But I think that should give me a pretty good shot at designing this stuff. Guys, 90% of the work is done now. 90% of the work is done. So let's say, okay, now let's start sketching. So I'm going to say create a sketch. I'm going to sketch in the XY plane. One more parameter I need to put in there. If I'm going to have the base sitting next to the cap, I need to have a construction line that sort of puts them the right distance apart. So I'm going to just put another parameter in here that I am going to just call offset. And that will just give me the size of the construction line, the length of the construction line. And what I want that to be is the case width times 1.2. Why 1.2? As it gets bigger and bigger, it's further apart, so you're not designing them on top of each other. So it's just a convenient way to have them always close but not on top of each other. So I think that will work, and then I'll say okay. And I've started really liking to design. I like to design with a rectangle, and it's going to be a center rectangle. So I can start at the origin. I'm going to click, I'm going to drag, and now if if I want this thing to be 45, I type in 45, right? Wrong. I already set up the parameter table. It is case W. Okay, it is the case width. Now I tab, so then I come over here to this box, and now that is going to be case L for case length, and boom, there, look at that. I have got that all nice and ready to go. And so now what I want to do is I want to go ahead and I want to round those corners. And so I am going to get my fillet, and I'm going to say I want to fillet this to this. And then how big do I want that? I want that case R for the curvature, the radius of that. Okay, so I've got that parameter in. Then I also want that here. I want it here and here, and then I want it here and here, and you see how it's keeping my little case R here? That's good. And then I want here and here. Boom, look at that. So now I'm going to click enter, and there it is. Now what I need to do is I need to take this, I need to take this now, and what I'm going to do is I'm going to offset it, because what I need is, if you look here, I need to offset it out to here to create that other region. So what I will do is I'll come up to modify, I will create an offset, and then I'm going to click this, I'm going to offset it. I would want it about 5, right? No, I want it what? The case T for case thickness, and boom, look at that. Did I do that right? No, I think I didn't do that right. Let me cancel that. That offset to the inside, which kind of surprised me. So I'm going to come over here and I'm going to say modify. I'm going to offset. I'm going to select this. And for some reason, it's wanting to offset to the inside direction. And so I don't want that. So I will say minus, so it will offset out. And I want it to offset by case T for case thickness, and boom, there it is. And so that looks really good, exactly what I wanted. But what you also want is you want an offset that is halfway, right? Because we've got to create this overlap region up here. So I need to make another one. And what that is going to be is it is going to be an offset. I'm going to offset this. I'm going to offset it by minus, so again it goes out, but this time it's going to be case T what? Well, I want it halfway. I want it halfway between the two. So case T divided by 2, like that. And boom, look at that. Now that looks really good. Now guys, I tried for 30 minutes to copy and paste this thing and have it be fully constrained, and I just couldn't do it. And I just hate designing things that are not fully constrained. You can see we're fully constrained here. So I'm just going to redraw this again really quick. So I'm going to give myself a construction line. I come here and then I come out. And then how far do I want to come out? By offset. Remember, I defined that offset. Okay, boom, that gives me that position there. That looks pretty good. Now I'm going to come in with my rectangle. It's going to be a center point rectangle. I'm going to click here, and then this is going to be what? Case W, and then tab, and then case L, and then enter, like that, enter. And now what I'm going to do is I'm going to round this again. So I'm going to fill it this to this. And that was what? Case R for the curvature. And then I'm going to also fill it this. I'm going to also fill it this and this. And then I'm going to fill it this and this. And then I'm going to fill it this and this. And look at that. Now you see it kept my case R here. That's good. So I'm going to say enter. And boom, look at that. Now I just need to do my offsets. So I am going to come in and I am going to modify, and I'm going to do an offset. I want to offset what? This by how much? Case T, like that. And it went the wrong way again. So where did that go? I need to make that minus case T. That looks good. And now we'll enter. Now one more offset and we'll start extruding. So I will do one more offset, modify offset. I want to select this to offset, and then I want to offset by what? You should remember, minus this time, case T divided by 2. Boom, look at that. And we are fully constrained, which is really good. So I'm going to go ahead and I'm going to finish that sketch, and I'm going to get the home view. And I did not get a construction line, so I need to fix that. So I am going to edit the sketch. I am going to, how do I edit that sketch? I'm going crazy. Edit sketch, there it is. Okay, I thought it was going to go crazy. This, my friend, needs to be a construction line. Finish sketch. That looks good. Okay, so now this seems like a long way of doing this, but now everything is a fully parameterized model. So now what do I want to do to start with? Well, I want to extrude, and I want to extrude this, and I want to extrude that. And how far do I want to extrude them? Oh, 5 millimeters? No. Case T, like that. Boom. Okay. Now, I want to extrude this, and let's go back. Okay, case T, I need to hit enter again. Okay, and I need to turn my sketch back on. Now, I want you to look here. Now we're going to, I am going insane. That, for some reason, did very badly. Okay, let me try it again. Somehow I'd selected the wrong thing, so I'm going to extrude. I want to extrude this, and I want to extrude this, and I want to extrude it by case T. Okay, enter, enter, boom. Now I'm going to turn the sketch back on, and luckily this part didn't extrude. I don't know what I did wrong a while ago. All right, now let's do the easy one. Let's extrude. Now I really got to start with the inside. So let's extrude this. Okay, let's extrude this inside one. And what that is going to be is that is going to be extruded by what? Not the case height, but the base height. all right, the base height. But if I just do base height, it would be up to here. So it's base height plus that ratio times the cap height, right? That overlap. So it's going to be the base plus the overlap, all right? So we come back over here, and did I lose that? Where is my little parameter? I think that it finished that, so I'm going to have to go back, okay? And so let's think about it. So what am I going to do? I'm going to extrude this, and it's going to be by how much? And you guys can see that. Well, it's going to be the base H, all right, the base H, and then it's going to be plus the base H plus the overlap H, the overlap H, that much, okay? Enter. So let's go back and look. It's the base height, which is this much, plus the overlap height, which is that much. Do you see how easy it is if you define your parameters well? Now we're going to extrude this. Okay, now watch this. That is going to extrude simply how much? Base H for base height. Enter, enter. Boom. Look at that. Okay, do you see the power of what we're doing now? Okay, I'm now just putting my parameters in, and I'm not even having to think that much. Okay, now what do I need to do? I need to come in and I need to extrude this one, and that one is going to be this one, right? And so that is going to be, we're going to do this inside one. How far do we extrude that? The cap H minus the overlap. The cap H minus the overlap. See if that makes sense when I do this. So I'm going to extrude the cap H minus the overlap H. The magnitude, not the percentage, the magnitude, the overlap H. Boom. Okay, so now what we want to do is we want to extrude this one. And that one is going to simply be extruded by, that one is simply going to be extruded by the cap H, like that. And then I'm going to say enter, and boom, look at that. Okay, now what is the absolutely amazing thing about this? The absolutely, I'm just thinking here for a second. This is always going to be the same as this. This is always going to be the same as this. Okay, so that is absolutely amazing now. So where we are now, and I'm just trying to think, do we really have this thing done? Do we really have this thing done? This now is kind of like what we had here, but now it is parameterized. And so let's come in and let's start doing some crazy things with our parameters. And so what I'm going to do is I'm going to come in and I'm going to say change parameters. And let's see, I want to get this where you can see the parameters and you can see the design. And so what if we made the case width, like what if we made the case width 125 and then we made the case height, 40, okay? And what if we did that, like that? Now look at this. What we have is we have a totally new concept. We have a totally new concept for a glasses case where instead of going in like this, it goes in like this. Now when I did that, what I see is, what I see is that this now is a little bit, this is a little bit narrow. And so what I think is I want a little bit more fraction on this top part, right? I don't want so much in the base and not enough in the cap. So I'm going to thicken up the cap a little bit. And so here for the same percent, instead of 75, I'm going to make that 0.6 like that, okay? And so now what happens? Now I have more. I have more in the cap and less in the base. Okay, and let's see, what did we say the cap length was? 25. I think I'm going to make that 20. I'm going to bring this down to 20, like that. Okay. Wow, look at that. That's like I say, that is a whole new concept. That is a whole new concept for this. What we could also do is, what if we switched the length and the height and we made, okay, I'm trying to edit this. We made this one 20, and then we make the length instead 40. And now we have a new concept where the glasses would fit in like this, and then the lid would pop on. So you see, all of a sudden we are doing some pretty crazy differences. What if we wanted to make this really tall now? And so that would be case height. What if we made this 250? Okay, boom, look at that. Do you see that in all of these cases, the design isn't breaking? The design is working, and now you can design any case that you want. Oh, for this one, I want the seam up a lot higher. So for that seam percent, I'm going to make that, let's say 85% or 0.85. Look at that. So now I have, it looks like a little, like what you would think the old cigarette cases or a tobacco can or something like that would be. Man, this is a really cool design. You can just go out and you can design all the cases that you want. But of all of them, what I kind of liked was, I kind of liked where this was on the height. I liked the height at 40, and then with the height at 40, and then I liked with the height at 40, I then liked the length at, I think, 25. Okay, and now you can clearly see that I need more. In fact, that might have just about broken it because the overlap looks like it doesn't work there, or maybe that overlap is almost the same thing. But what I need to do now is I need to make the seam percent, I'm going to make that like 0.6. Okay, and now that looks good. In fact, I think that might be a pretty dandy, let me make sure that 125 is enough for my glasses. Yeah, I think I better make it about 140 on the what is now the width. 140, like that, and boom. I'm just going to take a second here. That might be a little bit more of an overlap than I want, and so that overlap percent, the overlap percent I'm going to make 0.3. Okay, so you see that took it down where there'll be a smaller overlap there. Wow, could it really be that easy? Okay, guys, what I'm going to do is, what I want you to do now is your homework assignment is to play around. Hopefully you understand what I did. Man, leave me feedback. Do you see the magic that just happened? I have a fully parameterized model for a case, and I can make it any size I want, and it doesn't break. It's a generic case designer, a generic case creator, and you can create now any case you want, and the design doesn't break, and it's very easy to model. So what I want you to do is I want you to make a YouTube video and then link to it in the comments down below. In your video, what I want you to do is link back to my video so people watching it will kind of know what you're doing. And then I want you to show me on your video you playing around with your parameter table and creating a box that doesn't break. And then what I want you to do is just pick out kind of like a cool case and then print it out and show me that you can print a case based on your parameterized model. I hope that makes sense. Guys, I love this. I really got excited when I saw the thing actually coming to life. If you wanted to take it to the next level, you might make your curvature sort of a driven parameter, whereas the box got smaller, maybe your curvature got smaller. You might play around with that a little bit, but do it. Print out a couple of cases and then show me the results on your YouTube channel. Okay, guys, I hope you're having as much fun taking this lesson as I am making the lesson. And then what I need you to do is, if you like the video, be sure to give us a thumbs up. If you've not already, subscribe to the channel, and then share this with other people. Share this with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.